think they turned stuff up. Okay. I'm just going to think out loud. Just make sure you're doing okay here. Like terms, same base, same exponent, same variable, same exponent. So I have 6x squared plus 1x squared. So I have 7x squared. Then I just have a constant. We usually hang those out on the end. Okay, so we got that one. Let's see. Bunch of x's. Same variable, same exponent here. So those two are like terms. So I have minus 1 of those, minus 4 of those. So minus 5x to the third. Done with the 2 of those. And I don't have another x squared term, and I don't have another constant, so I'm just going to write it like this. And then let's see, a bunch of x's. There's one of them right here, so if I add all 3 of those together, I get 8x, and then I have a plus y. Did I do it okay? Zach?
1, 2, you didn't add the square with the 7x.
Oh, I didn't add the square. Thanks for catching that. Okay? All good? Okay, I made a silly mistake. I dropped an exponent while I was talking, but I think we're in good shape. Is there a rule on how we have to write the 8x and the y? Does it matter which one goes first? Usually alphabetical order with the constant at the very end, okay? And raise your hand if these were all easy, okay? Keep your hand up if you wrote it just like that. Okay, good. Then we're kind of ahead of the game. I'm hoping that most of this is a review. So we're going to go over some ideas that deal with polynomials. Okay, and I think I wrote that up here. Yep. So add, subtract, and multiply. No division yet. No division with polynomials because, as we've talked about, division introduces some weird stuff. So an expression made of a single number with no variables is called a constant. So any number you want. 5, negative 7.2. Would that work? Is pi a constant? Yes, it is. It's an irrational number. It's a plain old number. It's not going to change. Okay, so that's a constant. A constant, a variable, or a product of a constant and a variable is called a term. So 2 is a term, x is a term, negative 3x squared is a term. If I write 12x or something like that, as long as it is one single product of things, or single variables or single numbers, then we'd call that a term. Okay. The part of a variable term, the number part of a variable term is called so it's the thing in front. What's that called? Brittany? Coefficient. So coefficient. So for 8, so I've got the kind of the definitions or the explanations over here and then the examples on this side. So for 8, the coefficient is, 8x, the coefficient is 8. For negative x squared, what's the coefficient? Sai? It's negative 1. Okay, understood to be negative 1 there. Okay, terms with the same variable and the same exponent, or another way to say that is if they have the same base and they have the same power, okay, those are called blank terms. Brittany? Very good, like terms. So if I have 2x squared and negative 7x squared, those are going to be like terms. If I have a 5x and as long as it's got the same base, meaning same variable, and the same exponent, then I'm fine. So you can put any number you want on here. I could get really tricky and put a pi on there because that is a number. I'm just going to put a 3. And when we combine all these together, so if we take a bunch of terms that are made up of constants and variables raised to, would you underline a non-negative integer exponent? Then we get something called a polynomial. A polynomial. So it's kind of like polynomial. We don't really kind of pronounce the Y like we should. Okay, so here's what we're looking for in a polynomial. There are no roots, no fractional exponents, no variables in the denominator, so you can't have an x in the denominator, okay? And the terms are separated by pluses and minuses. So this is a perfectly good polynomial. Even though it's got something in the denominator, even though it's got a fraction, what's in the denominator is a number. That's totally okay. That's just the number 0.75. We're okay with that. This one is not okay. Okay, what's not okay about this? Luke?
The exponent is
negative in the exponent, okay? So the problem here is the negative exponent. What's the problem on the next one? Brittany? It's got a root. Okay, which also, if we think of it in terms of exponents, is to the 1/2. It's a fractional exponent. That's not okay. So we can't have a root. The next one, fractional exponent. And what's the problem with the last one, Jack? What's the trouble here? The x is in the denominator, which, okay, it's in the denominator, clearly an issue. But if you wrote it as an exponent, what type of exponent would it have? 1 over x is the same as x to the negative 1. So it would have a negative exponent. That's not okay. This one, that first one right there, you could write that as 1 over x squared. So a negative in the exponent is going to make it so that it's in the denominator. Okay, polynomial with one term is called a, anybody know? Monomial. So 6x squared. Technically, if I just wrote a 3 there, we could think of that as a polynomial. It's just got one term. 2 terms? Dane? Binomial. And they get really tricky here. 3 terms is called a trinomial. Once we get that past that, we usually just say polynomial. We could call it a quadrinomial or something like that. We usually just say polynomial once we get past that. So any 2 terms that fit this definition right here would be totally fine. So I could do 6x squared minus 7x to the 4th. I could do that one, and I could just leave off that 3/4 there. As long as I have 3 terms here that fit this definition up above, so I could do a negative x squared plus 7x minus 9. That would be a trinomial. Okay, we usually write polynomials in standard form. So here's how standard form works. We write the variable term with the highest exponent first, then lower exponent terms in descending order with the constant term, if there is one, we write that at the end. Okay, and there are times where people don't call it standard form. They just say, we're just going to write this in descending order. And the obvious reason for that is, I mean, it literally says what we're doing. We're writing them all in descending order. So this is a polynomial that's in standard form. It's in descending order. The highest exponent is 4, then a 3, then a 2, then a 1. And then technically, you could write an x to the 0 there, because any number to the 0 power is 1. But that's what it looks like in descending order, so we call that standard form. Okay, the exponent of a term gives you the degree. So would you write the degree of the term? And then would you put a star by the next one? So each term will have a degree, and the polynomial has a degree, and the degree of the polynomial is whatever the highest exponent is. So the degree of the value of the degree of the largest exponent, or the value of the largest exponent, is the degree for the entire polynomial. So for the one up above, the degree of this one is degree 4. The degree of this term is degree 3, degree 2, degree 1, and degree 0. But the polynomial, if we said, hey, what degree is this polynomial? We just say what the highest one is. What's the biggest one? So that's degree 4. Okay, and then the last vocabulary we're going to talk about is the leading coefficient. So the leading coefficient is the coefficient of the first term when it's written in standard form. When it's written in descending order, okay, what's the leading coefficient? It's the coefficient of the leading term. So in this case, it's the 2. So a lot of times we'll use function notation when we're talking about polynomials. So there are some examples here. So here's the name of each one of these. So we've got a linear, a constant, a 0, a constant, a linear, a quadratic, and a cubic polynomial. So there's only one 0 polynomial. It's literally just f of x equals 0. Okay? A constant is any number right here. And again, most of these, if we use an a can't be 0. A linear one looks like this, a times x plus b. A quadratic, so you want to keep track of that name because that's going to come up again. A quadratic is ax squared plus bx plus c. And then same type of thing for a cubic. We're just kind of adding another exponent, another term there, increasing the degree one at a time. And those are the names. So the degree of this polynomial right here. Think about it for a second. This one is degree 0. Anybody know why this is degree 0? Gave you a hint up above. Brittany? Because there's no variable. If there was one, it would have to be to the 0 power. That's why. Okay? Why is this one degree 1? Because technically there's an exponent there, right? This would be degree 2, and this would be degree 3, which kind of matches up with the fact that this is cubic. This is quadratic. Quadratic means square. Okay, so that's why there's a 2 and not a 4. Okay, so what do you think about this one right here? Do you think it would be degree 0 or something else? Told you we were going to argue about 0 a little bit today. Yeah.
I think it would be degree 0 because it's x.
Because couldn't you put an x to the 0 on there? Isn't this just a special case? Isn't the 0 polynomial just a special case of a constant polynomial? I think that too. I would accept either 0 or some people say there is no degree. And again, that gets back to the idea that 0 kind of creates a trivial case a lot of times. So if we write down an example, there's only one example for the 0 polynomial. Oops. Any number will do here. So if you want to say f of x equals 7, put f of x equals 7. And as long as a is not equal to 0, all we have to do is have a term with an x on it, and we're in good shape. So technically, that meets the definition. If I wanted to put a negative, let's do a negative 3 in front of that, that would be fine. Do you have to have the stuff that comes after it? Do you have to have a constant? No. So take a look at the very last one. We've got a quadratic right here, but take a look at the last one. Is that okay? Is it okay that we just have 5x to the third and then minus 1? Do we have to have everything in between? Answer to that is yes, totally okay. That is a cubic polynomial. Okay? Happens to be a binomial, happens to only have 2 terms. This one has 3 terms, that one has 1 term. So monomial, 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 trinomial here. That one's a binomial, but it's still a degree 3 polynomial. It still qualifies as a cubic. Okay, any questions? All right, flip the page over. Now, I was looking at my notes earlier today, and I thought I'm going to make this a little bit easier because I have really crappy handwriting, if you haven't noticed. Okay, mine has the yes, no, degree, and leading coefficient. Look at the instructions. That's just going to make it easier for me. Okay, you'll just have to write down the word yes and no and then keep track of the degree. Are the following functions polynomials? Yes or no? If yes, write in standard form, then state the degree and the leading coefficient. If no, explain why not. So take a look at this one right here. I'm going to ask Wilson. Wilson, is the answer yes or no on A?
No.
No. Tell us what the problem is.
There's a negative in the exponent.
Okay. Negative expo. That's the problem. Which a negative exponent would make it so the variable's in the denominator. Okay. Next one. Jack, what do you think?
Yes.
It is a yes. So let's write it in standard form. So that would be plus 2x minus 9, or I can just write it like that. Degree? 1. Leading coefficient? 2. Okay, next one. Okay, Angela, is that a polynomial? Is there anything here that messes it up? Crew, Mason's not here. Will you pull the door shut? Cube root of x, not allowed. Okay, so the answer on this is no. So I'm going to cross these guys out. It's not going to have a degree. It's not going to have a leading coefficient because it's not a polynomial, or the way we're going to talk about it here. So one of the problems is we could say cube root of x, not allowed. There's some other issues here. That's a fractional exponent. You could write that down. And the issue here is we've got a variable in the denominator. There's 3 different reasons at least that you could put that this is not a polynomial. Okay? All right. Zach, how about the next one?
Yes.
Yes, it is. What's the degree?
0.
Degree 0. Leading coefficient?
13.
Great question. Is there a leading coefficient? What's the coefficient again? What's the coefficient? Keely? Yeah, it's the number. It's the number in front of a variable. It's the factor in front of a variable, that numeric factor. So is there a variable on this one? Nope. So we're going to say none. There's not a leading coefficient on this. If you were going to say anything on this, leading constant is 13.5, but it's just a monomial. It's only 13.5, so we really wouldn't use that terminology. We take a look at the next one. Let's see. Abby, what do you think? Yep, it is. So we're going to write it in descending order. So we're going to write negative 5x squared plus 4x. Lizzie, what's the degree? 2. Samara, what's the leading coefficient?
Negative 5.
-5. Okay. And Dane, how about that last one? Yes or no?
No.
Dane says no. Okay. I'm thinking he's saying no. I'm thinking this is the problem right here. We got something in the denominator. Can't have any denominators. So the answer would be no. Agree or disagree? Anybody want to straighten us out on that? Is this a yes or is this a no? Is that a polynomial or not? Colson.
It is because it's only if the variable is in the denominator.
It's only if there's a variable in the denominator. Dane, were we right? Is it the 2 that was screwing you up?
Yeah.
Okay. All right. So the answer on this one is yes. Take a look. Is it already in standard form? Yes, it is. Because we've got the highest exponent right here. We skip to the 4th. We skip to the 3rd. We skip to the 2nd. Then we've got to the 1st, and technically we've got x to the 0 there, already in standard form. So what degree is it? Degree 5. Degree 5. What's the leading coefficient? 2. Okay. Any questions? All right. Last little bit. All we're going to do now is we're just going to do some arithmetic with these. Couple things. If you're adding or subtracting polynomials, first of all, be careful with signs. People make mistakes with this all the time. I make mistakes like that. So be careful with the signs. We're going to combine like terms, and then we're going to make sure that our answer is in standard form, okay, because we want to be able to easily compare our answers. If you're multiplying, you want to be careful with the signs and the rules for exponents, okay? So people forget those all the time. Combine the like terms. Make sure your answer's in standard form. So if it's written like this, we're going to take this polynomial and we're going to add it to that polynomial. While that's coming around here. If we're adding these together or subtracting these and we've got them in parentheses, you can always take the parentheses off the first one. And then basically this is what we're doing. We're adding every single one of these. So if I add x to the 3rd, and I add positive 2x squared, and I add negative 5x, and I add positive 3, the plus sign is not going to change anything here. Now, to me, this is a little bit of a waste of time, but it does make things more clear. I'm just combining like terms. I'm putting these all together. That's what the plus does. It doesn't change the sign of any of these. We don't need the parentheses or anything. So now we can go through and we can just combine the like terms. So this is 3x to the 3rd. Notice automatically we're going to gravitate to that first one in line, whatever the highest exponent is. Then we're going to take the squared terms. So that's going to be negative x squared. Then I'm going to take the plain old x terms. That's going to be negative x. And then I've got the constants on the very end. So that's going to be a plus 2. Now, would you double check my quick arithmetic? Because I was talking, writing. I don't know if you can call that writing. That's really pretty crappy writing. Did I get it right? Was I careful with signs? Is it in standard form? If you were asked, what's the degree of each term? Would you know what the degree of each term is? And if you were asked what the degree of the polynomial is, would you know that? And if somebody said, hey, what's the leading coefficient? Would you know what that is? If so, then we're in good shape. Okay, subtraction is a little bit different, so I'm going to blow this up just a tad. Here's what I like to do. With addition, I just kind of imagine the problem without the set of parentheses. With subtraction, I'm super careful with this because people make mistakes like this. So I'm going to write that first one down again, and then I'm going to subtract all 4 of those. So that's going to be negative 2x to the third minus x squared plus x and minus 2. Now, if you can do that in your head, great, but don't make any mistakes. Because if you make one mistake, you're going to get the answer wrong. It's going to get frustrating. And when you start doing more complicated things with polynomials, if you're in the habit of skipping steps and making little arithmetic errors in your head, that's going to cause an issue. So we're going to go through and notice, oh, wait a minute. That's an x squared. Here's the highest exponent right there. Then I can put the two of those together. And then I've got a minus 6. Did I do okay? All right. We're just going to distribute the negative 5x squared through, so we're going to get a negative 15 for the coefficient, x to the fifth, positive 10 for the coefficient, x to the fourth. Same base, we're multiplying them together, so we add the exponents. Multiplying here, we get negative 30 x to the third, and multiplying here, we get plus 40 x squared. Whoops. Okay. Any questions? Okay, everybody look up here. I don't want to waste your time. I want to get the homework in your hands as soon as possible. Raise your hand if this is easy. Okay. All right. Let's take a look at this one. I'll go through the next couple fairly quickly. So on this one, remember multiplying binomials from last year? Every term in this polynomial gets its turn being multiplied by that polynomial. So this is 5x times 2x, 10x squared. 5x times 9, 45x. Negative 7 times 2x, negative 14x. And negative 7 times positive 9, negative 63. Couple of like terms, this is really typical. 31x minus 63. We good there? Nobody's screaming at me, so I think I did okay. Okay. 3 terms here and 2 terms here. Here I had 2 terms and 2 terms. I ended up with 4 terms. Oh, come on. Just write the answer. This seems to be doing this more to me lately. There we go. Okay. So 3 terms, 2 terms. 2 terms here times 2 terms here, we ended up with 4 terms that we then had to put together. 3 terms here times 2 terms here is going to make how many terms? It's going to make 6 terms. So all we have to do is be careful with stuff like this, and we're going to get the right answer. Let's see. So we get x squared times x, and x squared times negative 3. So that's x to the third minus 3x squared. Then it's this one's turn. Oh, that's interesting. And then I'm going to change colors for this last one. Red. Negative 2x and plus 6. Oh, look at that. Those go away. Done with that one? You do okay? All right. Any questions there? Okay. Would you do the last one? I'll do that on the board in just a second. Is anybody done? Is that what you got? No. Did I mess up? Did you do it the long way? Wrote them all out?
No, I just forgot to put the 5 to the squared, and I just did like the 5.
Oh, you did 5x to the 6th. Okay, common mistake. Okay, remember that pattern I was talking about that I said happened a lot? I'm going to write 5x to the 3rd minus 1, and I'm going to multiply here. That's going to be 25x to the 6th. Then I'm going to multiply here. That's going to be minus 5x to the 3rd. Then this one gets its turn with both of those. So that's going to be a negative 1 times 5x to the 3rd. That's minus 5x to the 3rd. And a negative 1 times a negative 1 is a positive 1. 2 terms times 2 terms. It doesn't matter that it's raised to the 3rd power. You're going to get 4 terms. And these middle ones, most of the time, but not always, most of the time they're going to have something to do with each other. They're going to be like terms. We put them together. So I got a 25x to the 6th minus 10x to the 3rd plus 1. Luke, what's the degree of the second term in this polynomial?
3.
Good. Okay. All right. On the homework. Okay. So I'm going to stop this recording here.